All right, in this question, we're looking to solve for Gibbs free energy using a known enthalpy and entropy value. So we're not using the sum of products minus reactants in this equation. We're using the Gibbs free energy equation, which we have to know temperature in Kelvin. So make sure it's in Kelvin. And the biggest thing to be aware of besides the Kelvin temperature thing is the fact that we have kilojoules in one and joules in the other. So those have to be converted. In this case, the answer is looking for kilojoules per mole. So we're going to convert the joules to kilojoules. So first thing we're going to do is lay out our numbers. So we have delta G equals our enthalpy, which is 25.22 kilojoules per mole. I'm going to minus our temperature, which is given to me in Kelvin, so 201, times our delta S. Now I'm going to convert this beforehand, so I'm going to say 84.48 joules per mole Kelvin. And I'm going to say there are 1,000 joules per 1 kilojoule. So I'm essentially dividing that number by 1,000. So I'm going to get 0.08448 kilojoules per mole Kelvin. So I'm going to multiply that by 201. 201 times 0.08448 equals 16.98. So 25.22 kilojoules per mole minus 16. And then 25.22 minus 16.98 is 8.24. So now we can look at a few things. Does this answer make sense? Let's do our gut check, right? So we have an enthalpy that is positive. So it's endothermic, which does not favor spontaneity. We have a delta S that is positive. So that is entropically favorable. So this is one of the ones where they're both the same sign, plus and plus, which means it's temperature dependent on if it is spontaneous or not. In this case, our temperature is not high enough to make it spontaneous because we have a positive delta G. We need a negative delta G. So we would actually need, if we had a higher temperature, it would be spontaneous. And we could solve for that temperature by doing delta H over delta S, which is 298 Kelvin. So if it was at room temperature, it would actually, or above room temperature, it would be spontaneous reaction. But at 201 Kelvin is not. So let's put in our number, 8.24. And there we go. So make sure it's in Kelvin, which is given to us in this case, and then make sure our units are the same throughout, kilojoules.